Hi everyone, welcome back to Sky Appliance YouTube channel. Today we're going to build a dim bulb tester, a super handy tool for safely testing electrical devices. If you're into DIY repairs, you'll want to have one of these. So what is a dim bulb tester? The tester puts a light bulb in series with the device you're testing, so if there's an issue, the bulb absorbs some of that power. If your device is drawing too much current, the bulb will light up instead of damaging the device or popping your circuit breaker. Sometimes when I'm doing a live test, the test power terminals or alligators might accidentally touch each other and create a short circuit. Normally this would trip the circuit breaker and could potentially damage something. But with this device, it lights up to signal that something's wrong, and it protects the circuit from damage. Traditionally, people build these testers with a large 100 or 200 watt incandescent bulb. But honestly, those bulbs are a bit bulky and easier to accidentally knock over. Plus, they have higher resistance, which can affect the test's accuracy. Today, we're going to use 8G9 60-watt halogen bulbs connected in parallel. This setup gives us a compact design with lower resistance, allowing for more accurate results. Here's the calculation. One 60-watt bulb has a resistance of 240 ohms. With 8 bulbs in parallel, the total resistance comes down to 30 ohms. Imagine you want to test a device or part with 250 ohms of resistance. A tester made with a 100-watt bulb adds 144 ohms, over 50% of the device's resistance. But by using 8 60-watt bulbs in parallel, we add only about 30 ohms, or roughly 12%, allowing for more accurate results. Please pause the video to read this important disclaimer. Here's what you'll need. 8G9 60-watt halogen light bulbs. I got this pack of 10 from Amazon. 8G9 base sockets, one for each light bulb. I got this pack of 10 from Amazon as well. I couldn't find a compact fixture to mount 8G9 sockets, so I picked up an outdoor outlet cover from Home Depot to hold the bulbs. To connect the wires, I got some wire nuts and Wagos, and also considered soldering the wires. In the end, I didn't trust the large blue wire nut for connecting 9 wires together, so I went with the Wagos. They're easy to work with and make it simple to add or remove sockets in the future. We also need an appliance power cord or an extension cord. I wanted a white wire, so I'll use this one, which is rated for 15 amps. Plenty for my needs. For the power outlet, I picked up this on-wall kit from Home Depot. It's pretty neat. We'll also need a piece of wood as a mounting plate, and here's a plug-in on-off switch to give us more control, which I got from Home Depot as well. Using wire clamps to secure the wires is a great idea. Unfortunately, a metal clamp like this one doesn't work for this setup, so I ended up getting these 3/8-inch plastic wire clamps. Let's put these parts together. I stripped the ends of the wires to connect them to the outlet and removed the cable coating about 1 foot before the end, which will sit inside the box. I also split the black wire to connect it to the light bulbs. Now I'm going to use Wagos to connect the sockets in parallel. I'll use each slot to insert 2 wires. The brown wires will go into one Wago, and the blue wires will go into the other. So 4 slots of each Wago are filled with wires, leaving 1 slot available for connecting the black wire later. Now I'm going to connect the hot, neutral, and ground wires to the receptacle. They are usually marked, as you can see in this picture. Since these wires are stranded, you may want to make them solid using a soldering iron if you have one. For the ground wire, I'll use a piece of solid wire to provide an extra connection to the box as well. There are plenty of videos out there showing how to connect wires to a receptacle properly. I typically make a hook and insert it from the right side of the screw. This way, when you tighten the screw, the hook gets tighter and stays secure. Also, make sure to fully tighten the empty screws to prevent any contact with the ground wire. If you're finding this video helpful, please give it a thumbs up and subscribe to the channel for more DIY and appliance repair tips. I'll secure the base of the outlet to the mounting board, and I'll knock down the side port to pass the wire through. I'll connect the ground wire to the base, and then I'll use the screws that come with the outlet kit to assemble the outlet. Now, I'll insert the 2 black wire ends into the 2 empty slots of the Wagos. I'll use 2 screws to secure the box to the mounting board. Then, I'll place the bulbs inside the box, pass the 2 white cables through the 2 ports, and close the box. Now, I'll quickly test to ensure there is no continuity between the line, neutral, and ground wires. Let's give it a try. I'll connect the alligator clips to the multimeter and turn on the switch. The multimeter is showing 120 volts between them. Now, I'll test an infinite switch. If the switch is shorted, or if the alligator clips accidentally touch each other, it won't trip the breaker. Instead, the light bulbs will simply light up. Let's test the current draw in the case of a short circuit. I've created a short circuit by connecting the line and neutral wires with a Wago. I've also separated the hot wire to measure the current using a clamp multimeter. Let's turn on the switch. The lights have fully come on, indicating a significant short circuit. The circuit is drawing around 3.8 amps, which means the total resistance is approximately 30 ohms. When there's a short, these bulbs generate a lot of heat. As you can see, the temperature reached 126 degrees Fahrenheit in just a few seconds. So you'll need to turn off the switch and locate the short circuit. If you have found this video helpful, please give it a thumbs up and subscribe to the channel for more DIY and appliance repair tips. Thanks for watching, and I'll see you in the next one.